continue solving math applications, SL, paper 1, May 21. Let's get started. Question number 12. Ellis designs a gift box. The top of the gift box is in the shape of a right angle triangle GIK. So here, triangle GIK. A rectangular section HIJL is inscribed inside the triangle. So this is a rectangle inside this right angle triangle. And the length is given P centimeters, Q centimeters here, 8 centimeters and 6 centimeters. The area of the top of the gift box is a centimeter squared. Find capital A, the area, in terms of P and Q. So mainly we need to find the area of this triangle. We know that area of a triangle is half base times height. We can use this formula because here we have right angle triangles. So one side will be the base, the other side will be the height. Here, these two sides of the right angle triangle. So we would write area equals half bracket. This side, this is, because this is here, JL is 6, so this is also 6. So this whole side is P plus 6. And because of this 8, this will be 8. We know it's a rectangle, so here all this side will be Q plus 8. So area equals half P plus 6 times Q plus 8. That's it? Yes. So this is our part I. Double I show that A equals 192 over Q plus 3Q plus 48. We already found the area, but here this expression is only in terms of Q. Means that we need to replace this P and we need to write it in terms of Q also. What does it mean? This means we need to find a relation between P and Q using this triangle and the rectangle. So how we would find a relation between P and Q? In this small triangle here, if we'll consider this angle is theta. So because of similarity, if this is theta, so definitely this also will be theta. Why? Because if this theta, the angle G, it exists in the small triangle GHL, and also it's exists in the GIK, in the big triangle. Means that here we have 90, we have theta, so angle K is the same angle K in this small triangle. So we have in the big triangle, we have theta, we have 90, we have K. So if we look to this small GHL, this is 90 because the rectangle here. So we have 90, we have theta, so definitely this will be the same as this angle K. The same situation in this small triangle JLK. Angle J is 90, so 90 K theta, 90 K theta. In the big triangle, 90 K theta. So this is similarity properties of similarities, these all angles are the same. So this angle theta is the same as that theta here. Is this useful information? Of course. In triangle GHL, if we need to find tan theta is opposite over adjacent. Opposite here is 8, adjacent is P. So 8, tan, opposite over adjacent, 8 over P. And from the other triangle here, we can say that tan theta opposite is Q, adjacent is 6. So Q over 6. And because this is, here we are talking about the same angle theta, it's the same angle, so 8 over P equals Q over 6. Cross multiply, PQ equals 48. So P equals 48 over Q. So this is the relation between P and Q. P equals 48 over Q. Now, to get this area, the required, show that area equals this expression, what we're supposed to do is to substitute P equals 48 over Q in the expression that we found. Area equals half, and instead of P, it's 48 over Q plus 6, Q plus 8. Now we will open the brackets, we will keep the half for now. Area equals half 48 over Q times Q. It will be just 48. Q down here, Q up will be cancelled. 48 over Q multiplied by 8, it will be 384 over Q. Then 6 times Q, 6Q. 6 times 8 is 48. Now let's distribute the half. Area equals 24 plus 192 over Q plus 3Q plus 24. 24 plus 24, so we are getting the required expression, 192 over Q plus 3Q plus 48. So this is the required expression. B, find dA over dQ. We need to find the first derivative of this expression of the area. So to find the first derivative, it will be better to rewrite this area, A equals 192, and this Q, instead of denominator, we will write it up, power minus 1 plus 3Q plus 48. So now dA over dQ is negative 1 times 192, it's negative 192 times Q. This exponent minus 1, it will be minus 2. Then 3Q, the derivative will be just 3. And the derivative of 48 is 0. So we will not write this 0. We may leave our answer like this or write it as negative 192 over Q squared. This Q, we are moving this Q down, plus 3. Both are correct. This is B. Ellis wishes to find the value of Q that will minimize the area of the top of the gift box. Write down an equation Ellis could solve to find this value of Q. So we need to find the equation to get the Q, the value of Q, which will make the area minimized. So at minimum, we all know that at minimum, f dash is equal to 0. What is f dash? This is the derivative. So dA over dq is equal to 0. So our equation will be negative 192 over q squared plus 3 equals 0, and this is our answer for I. This is the equation which needed to make the area minimum. Double I, hence or otherwise, find this value of Q. So now we need simply to solve this equation to find the value of Q. So you will use your graphing calculator and open numerical solver, equation solver, copy this equation, and we will find Q equals 8 centimeters. Q is equal to 8. This is the answer for double I. So that's it for this question, and waiting for any requests, any questions. You can send me all questions into my Facebook page, my Instagram account, Twitter account. Also, any ideas, please comment in this YouTube video. See you next video. Goodbye.